All right, so we're going to go ahead and find the domain of the following. So if you notice here, I have a fraction. What was I going to do when I had a fraction? Set the denominator equal to 0. So t squared minus 1 equals 0. I need to solve that for t. What are you going to do? Add 1. So I get t squared to equal 1. What do you get now? Okay. Square root of 1, which is actually the plus or minus values of 1. Now, what happens when t equals positive or negative 1? What happens in my problem? Yeah, if it's negative or positive 1 right down here, what happens? Yeah, I get my denominator to be 0. Can you ever have a denominator of 0 in a fraction? No, it's undefined. You get that error. So as a result, I can use anything else but positive or negative 1. Because you could have a negative number in the denominator, can't you? Yeah, I mean, it's just dividing by like negative 2, negative 3. You can have a positive number in the denominator. The only thing you can't have is 0. So really, I could have anything else except for positive or negative 1. So how I'm going to write that is I'm going to do this. All reals except positive or negative 1. I will let you go with that. You could use set notation. I could have been really picky with that, but I want you to just be able to identify the values of t that work or don't work. Now, if you were going to use interval notation there, interval notation is going to be a little bit confusing because the interval notation is actually going to look something like this. And we will eventually get here to this step, just not right now. Yeah?
Where do you get the positive or negative one?
Because if I take the square root over here to solve for t, whenever you take the square root of both sides, remember you always take both the positive and the negative value.
Okay.
And so the positive or negative square root is positive or negative 1.
Okay.
Answer your question?
But wouldn't negative 1 minus 1 be negative 2?
You have to square it first. So negative 1 squared would actually be a positive 1. And then subtract 1, you'll get 0. Alrighty, let's look at the next one. It says state the domain of the function f of x equals x minus 5 over square root of 2x minus 3. Now this one, wow, we've got a square root and we've got a denominator. So let's start with the denominator. What did the denominator say that we do? Okay, 2x minus 3 equals 0. What does that come out to be if I solve that for x? Close, the other way, 3/2. Now let's revisit again what that 3/2 means. If I plug 3/2 in here for x, what does that make the denominator? 0. I know 0 is the boundary point between my negatives and my positives. So am I going to want to put in numbers less than 3/2 or bigger than 3/2? Bigger. So I'm talking about 3/2 all the way to infinity. Am I going to include 3/2 or not?
Yes.
Why not?
Oh my gosh.
Oh, because it makes it easier.
If you plug in 3/2, it'll make it 0. You can't divide by 0. So this one, you're going to have 3/2 to infinity. Good job. That one's kind of a tough one. Now, one of the other things we're going to do eventually, instead of doing this algebraically, I'm going to show you how to do it on your calculator where you actually graph these and then you visually try and find the domain. So, all right, let's look at this next one. It says state the domain of g of x equals square root of x squared minus 16. Now what I need to do is take x squared minus 16, set it equal to 0. As you're solving it, what do you get x to equal? Plus or minus 4. Now this is where it gets a little interesting. Okay, you have two values. Each of those values make it 0. So you have a positive 4 and you have a negative 4. So let's try to analyze. Okay, if I used the numbers, let's just do this because I think that'll make a little bit better sense. Would you agree that I have 3 intervals? I go from my negatives to negative 4. That's my first interval. My next interval would be from negative 4 to positive 4. And then my next interval would be from 4 to infinity. If that confuses you looking at it that way, let's look at it this way on a number line. At 4, this is where they equal 0. So now what I'm going to do is I'm going to evaluate each of those groups. So I'm going to evaluate number 1, number 2, number 3. And I'm going to see which of those intervals works. So if I take numbers less than negative 4, that's your negative 5 and your negative 6, negative 7. Will that work in here? So if you take negative 5, square it, what do you get? 25 minus 16, what do you get?
Negative.
Square root of 9, which is 3. If you take negative 10, square it, you get 100 minus 16. That will be a positive number you can take a square root of. So will that value work? That interval will work. Okay, so I know this one works. Do I include negative 4? Can I get 0? Can I get the square root of 0? Yeah. You can get the square root of 0. All right, so let's look at this interval, number 2. So number 1 works, that's great. Number 2, 0. If I plug 0 in here, I get 0 minus 16. Can you take the square root of negative 16? No, so that means this interval is out. You can't have that interval, it's done. Your last interval is from 4 to infinity, so let's pick a number bigger than 4. What number do you want to use? 5. Square 5, you get 25 minus 16, you get the same thing we started. So will this work, this interval? Yep. So I'm going to go from positive 4 to infinity, and that one will work.
So you get both of them?
You get 2 answers on that one. And in order to do that, if we were to properly answer that, we would probably use a union symbol. We would do our little U symbol. And so I bet the back of your book probably does that. Questions? All right. Last thing we're going to look at is what's called a piecewise function. Don't worry about writing this down. It's not necessary for you to write it down because it's really easy once you look at the first problem. This is something you'll see probably on your ACT. Something like this. Piecewise function means a piece of something combined with a piece of something else combined with a piece of something else. So it says realtors in a metropolitan area studied the average home price per square foot as a function of total square footage. Their evaluation yielded the following piecewise defined function. Find the average price per square foot for a home with a square footage of 1,400 square feet. So this is the number I'm worried about, 1,400. So if you notice here, I've got 3 separate functions. I've got this one right here, which says if A, the square footage is between 1,000 and 2,600, I'm going to use this function. I've got B, what square footage will this be? 2,600 to 4,000. And then I've got this one down here. What is this one for? Oops, having trouble with that. There we go. What size is this for? Bigger than 4,000. So which of the 3, the purple, the blue, or the pink, will I use here? The purple. So all I'm going to do is take 1,400 and plug it in right here to find my answer. You ignore the other 2. You won't use them on this problem. That's pretty easy, isn't it? Now say, for example, I wanted 3,500 square feet. Which one of the 3 would I use? The second one. So you're going to take your 3,500, plug it in here for A, and go through and solve. That's what a piecewise function is. It's very easy if you know what you're looking at. All right, so you think you can handle that? Assignment then for tomorrow is right there. 15 through 29. Actually, we got to change because that was 28. Okay, 15 through 28. Now that sounds bad, but that is just determine if it's a function or not a function, 15 through 28. It goes through very quick. In fact, everybody got done with that 4th hour today. 15 through 28, all. The next one was 30 through 36, the evens. Then what I ended up having was 39 through 44, and I'm going to double check because I think there might be a change there real quick. Let's see what we got.
Excuse me. What?
Oh no, that is right, 39 through 44, and then finally 48 through 50.
Just give chill, bro.
Yeah.
So that is your assignment.
Okay.